Hi, Nora.
Hey Bob,
How you doing?
pretty good. How about yourself?
I can't complain. Let me introduce us. I'm Robert Wright, publisher of Nonzero newsletter. This is the Nonzero podcast. You are Nora Belrose. You are at EleutherAI, a nonprofit AI research group that has kind of an interesting history that maybe we'll talk about. And you are head of interpretability, uh, which is interesting to me because that means one thing you're doing is trying to figure out exactly how these like large language models in particular, I guess, work,
Mhm.
which is something I'm interested in. And I'm interested in the fact that it's more of a mystery than one might have imagined at one point, how these AIs actually work. I mean, more of a mystery even to the people who built them. Um, uh, Interpretability is closely related to the field of alignment. The idea being that the more we understand about how they work, the easier it may be to align AI with human values, human interests. So reduce the chances that it will kill us all and in a quest for world domination or cause harms in less dramatic ways. So I want to talk about all that. Now, one interesting thing about you, compared to some people who are doing alignment related research, is that you're not that much of a doomer, right? You're more of an optimist than some of my past guests. So I guess the standard question to ask is, in your neck of the woods, I mean, in Northern California, the standard
Mhm.
question is, what is your P doom?
Yeah, so I'll start off by saying that, I don't really like the term PDOM very much. I think um, you know, many people who would even self-identify as doomers would also say that they don't really like the notion of PDOM, mainly because it's just kind of unclear what you mean by doom, right? Doom
I
could mean
was
a
going
lot
to
of different
ask
things.
that. Does it
Yeah,
mean out and out extinction, or does it mean just something pretty bad? Because pretty bad is a pretty vague term.
right. So I guess what I will say is um, so if you're kind of narrowing your focus down to failure modes that look like, the AI went rogue and then either killed like all humans or like took over in like a permanent way and it like most of the value of the future is destroyed. Something where like the AI goes rogue. I I am like on record as saying that I think this is like less than 1% likely. I'm not sure I would say it's like less than point. Basically, I would say it's like yeah, like less than 1%, maybe not less than like 0.1%, but something like that.
Our audience
Um,
just breathed a collective sigh of relief.
uh,
Um, and you mean like kind of rogue? You're talking about rogue behavior plus a concentration of power in the AI. I mean, there may be individual AIs that, in some sense, go rogue and go awry, and
yeah.
something bad happens. What do you think the average person in Northern California, in kind of roughly your line of work, what do you think they're thinking of? But when they say PDUM, because the funny thing is they give you an exact number. It kind of reminds me of artificial general intelligence, right? People will say, well, I think AGI will be achieved in like October of 2031. And you say, and what do you mean by AGI? And they say, well, I don't know. It's kind of vague, actually. So what do you think the average person in your culture means by doom?
Right. So I think that depends a lot. Or, I'm sorry, you said
Doom,
what they
first
mean.
Doom, first Doom. Yeah, I
So
mean, I mean,
what they mean by it.
I had thought for a while that they meant out and out extinction. That's
Mhm.
what Eliezer Yudkowsky, Doomer in Chief, means, right?
Yeah, yeah, that's right.
But do you
Um,
think most people who throw the term around and even give you a number don't mean that?
I think it's tricky to say. I do think that anecdotally, I don't have like hard survey data on this, but anecdotally, it does kind of seem like there has been a shift, somewhat of a shift away from concerns about um, like AIs going rogue and more discussion of like um, maybe there's like misuse, like terrorists are
Hmm.
able to create like, weapons that like eventually, like cause humanity to go extinct, or perhaps governments misuse AI to like install totalitarian states that can't be overthrown, things like that. I do sense that there has been kind of a shift. Um, but yeah, I think, you mentioned my culture. I think it really depends what you mean by my culture. I think if you're considering um, like all people in AI research in general, I think like most of those people are like not that doomy, and to the extent that they are doomy, they're like mostly focused on like misuse type
Hmm.
concerns. But if you focus more specifically on like Berkeley, California, or like
Hmm.
some of the people that I do collaborate with on research and stuff around here, I mean they are they tend to be like more worried about AIs going rogue, just because I don't know, for a lot of historical reasons, people who are worried about AIs going rogue have like geographically concentrated in like Berkeley and to a lesser extent like London. So
Hmm.
um,
Interesting. And Berkeley is also kind of the center for a lot of important work on AI, right? I mean, it's kind of I almost hear about it as kind of Stanford, it seems like, these days. But
um, yeah, I mean, there's a lot of stuff that UC Berkeley is doing, and there's also, I mean, there's like a lot of people that I know, like live in Berkeley, but they work at like either like OpenAI or Anthropic, which is just across the bay in San Francisco. So, SF and Berkeley are like pretty,
okay,
I mean, they're geographically close, so it makes
yeah.
sense that there's like a lot of connection.
So you used to be quite a bit more of a doomer, right? And you lowered
Yes.
your P doom considerably. And it was there kind of one simple reason for that, or
Yeah. So I think, I first became like really worried about like AIs going rogue when I read Nick Bostrom's book Superintelligence.
hmm,
Um,
which is
I
about
read
like
that.
10 years old or something.
Yeah, right. I think it came out in like 2013 or somewhere around there.
Very influential. I mean, all these people kind of read that, right? Like Sam Altman
Mhm.
read it and so on.
Yeah, Elon Musk and yeah.
Hmm.
So I actually read it a bit, I mean, a few years after it came out. I think it was in like 2018 or something like that. And I read it at a time when I really didn't know much about AI at all, honestly. I mean, I was familiar with like computers, I did like programming and stuff, but AI specifically, I really did not know that much about. But I read it and like kind of in the abstract, it seemed like pretty compelling. Like he made the case that like by default, when you build an AI that's like about human level, whatever human level means, but about human level, um, it will be able to recursively improve itself very rapidly. And also, there's kind of this idea within superintelligence that we're going to kind of write down what's called a utility function. The utility function is just like a mathematical, like formal description of like what the AI is supposed to value, what its goal is supposed to be.
Hmm.
And the idea, it's like I think Bostrom mostly assumed that like we would like there would be like programmers sitting down and like writing out, here's the utility function. And the worry was that, well, this seems like very hard. It seems very hard to like formalize human values, and like write it down mathematically because they're just complicated and like not really amenable to being formalized. And because of that, the worry was like, well, we're going to misspecify the AI's utility function on the first try, but then once we turn the AI on and it's like smarter than humans, it will resist attempts like to modify the utility function. That was like kind of the key worry that both Bostrom and Eliezer Yudkowsky were like first kind of worried about.
Hmm.
Um, and I mean, I can tell you about like why I don't really think that makes a lot of
Yeah,
sense now, but
I'd like to hear that. So the idea was that, like, to be clear on what the utility function is in the first place, like it would have a very precisely specified kind of guiding value almost, right? Like,
yeah, I mean, so kind of sort of by definition, it is like precise. It's a mathematically precise kind of
hmm,
object, and the idea is, it's a function because it takes in sort of a description of like the world, or perhaps it takes in like a set of observations that the AI has made, and then it like processes them and outputs a number. And if that number is high, that means like the AI is supposed to be like happy. It's like a good state of the world. And if it's like a low number, then it's
oh,
supposed to be
okay.
like sad. It's like a bad state of the world. and it's trying to like maximize the utility function, like get as high, like be, yeah,
So
like
in deciding what makes it happy, we would screw up. We would, is that right?
yeah, I think this was, and
We mean happy metaphorically for those
yeah,
who don't think it
metaphorically, right?
actually
Yeah,
has a subjective state. We just mean the thing it keeps doing, the thing that's defined as kind of positive reinforcement for it, in a sense,
yeah, I
or
think,
a goal.
yeah, and I think this was definitely like if you look back at like Eliezer's early work and Bostrom's early work, like this was a pretty important. I think actually on YouTube you can like look at like Eliezer did a lecture at UC Berkeley in like 2016, I believe, where he was like kind of laying out why he thinks that we're like AI will likely, or like at least why it's like very hard to like make an AI that doesn't kill everyone. And kind of the center piece of his argument is that the AI will need to have a utility function. We're going to need to like write it down or like program it. And this is very hard.
Mm-hmm.
And I guess maybe to kind of preview why I think like what we've seen in the last few years with the development of things like large language models is that basically we don't need to have a human sit down and program like, okay, here's like all of human values. What we're actually doing is we're using machine learning to sort of implicitly extract human values and human common sense, et cetera, human concepts out of all of the data that we've amassed on the internet. And so in some sense, it's a much more natural way of learning human values and human concepts, I think, because, obviously when you have a child, like you don't program like a utility function into it. What you do is you just like, the child learns from the people around it and just kind of implicitly like becomes enculturated
Mm-hmm.
into the culture and kind of develops certain values. So I think we're doing a similar thing with AIs, and I think that because of that, like this kind of traditional argument for doom doesn't make much sense.
So, in other words, I mean, if you large language models train on all this text that was generated by people, and they're trained to say the kinds of things that people say according to
Mm-hmm.
this text. So it stands to reason that the values implicit in the things they say would have some pretty close correspondence to human values
Mm-hmm.
in some sense. I'm not sure that's enough to reassure people, but that's what you mean by the values are implicit in it,
Right.
and they kind of emerge from the training and the data set and the fine tuning and everything, and you don't program into it values per se.
Right. Yeah. I think values are sort of a special case of just concepts, right? Like I think, um, for a long time in AI, like back in like, like well before this new kind of deep learning revolution that we've seen recently, it's been kind of hard to kind of precisely specify like human concepts. Like what is the concept of goodness? What is the concept of a dog even? Like how do you like look at the pixels of an image and determine whether there's a dog in there or not? Like that actually turns out to be like very difficult because the concept of a dog is just like actually complicated when you kind of like try to specify in terms of pixels. So there's like a general problem in AI is like trying to kind of get computer programs to understand human concepts. And I think that yeah, deep learning has just largely solved it, honestly. I think it's
Mm-hmm.
like pretty clear that through learning and big data we can learn these concepts, and by extension we can learn values.
Right. I mean, it seems to me that is kind of the revolution. I mean, when I first started thinking and writing about AI just as a journalist, the assumption, at least that I had, was that like, if you had something that could talk intelligently, you would have to program into it the meaning of the words and figure out a way to do that. But it turns out that no, you just teach this thing to predict sentences, and then it forms internally, in a sense, a landscape of meaning where it arrays words, but it figures that out itself, right? Um, and so too for with concepts, and so we there's this thing called concept erasure that I've heard you talk about a little, like the idea that you might want to find a concept in the large language model and erase it? I guess you might want to do that for alignment reasons. Is that right? I mean, like, before
Mhm.
we talk about how you'd find a concept, what kind of concept would you want to erase?
Right, yeah. So I think this is a good question. So one one area in which like concept erasure might be useful is during safety evaluations. Um, so like for GPT-4, before GPT-4 was released, OpenAI did, well, they did both kind of internal safety evaluations where they're kind of testing what GPT-4 would do, um, when you kind of prompt it to hack into a computer or something like that. They did internal things, and they also actually asked an outside organization to do safety evaluations. Now, in these safety evaluations, there's there's a worry that some people have, and honestly, I'm not that worried about it, but there's a worry that some people have, and it's at least kind of theoretically possible that the AI might, like during the safety evaluation, it might notice that it is being evaluated, basically. If it's smart enough, like maybe it like kind of realizes that it's being evaluated and then behaves differently. Like because it realizes that it's being evaluated, um, it will pretend to do what you want it to do, and it will pretend to be aligned or safe. But then in deployment, when it's like not being evaluated, it will do something different. And so one thing you might want to do to sort of uh, reduce the chance of stuff like this happening is to erase specific types of information from the AI's brain that we think it might be able to use to like tell whether it's being evaluated or not.
Mm-hmm.
And the specifics of this could get like kind of technical. It would depend a lot on like exactly the setup that you're using for evaluation. But like you could, I don't know, like try to make sure it can't like try to erase the concept of like the date, right? Like if it, it might, if it's like, it might be able to like look at the date and say like, oh, it's like 2050. I'm probably in deployment. That's like something that people have like thought about, and so you might want to like erase the concept of date or something like that from its brain.
Okay.
Does that kind of make sense? Um,
Kind of. I mean, I want to get more into the issue of finding concepts in these
yeah, yeah.
things. But first, I have a question about how reassured we should or shouldn't be by like the way the AIs implicitly absorb values
Mhm,
by virtue of becoming good at human conversation,
mhm,
kind of, right? And I mean, in a way, I would think it might be the opposite of reassuring because, like, when I first heard the Yudkowsky scenarios, like, oh, the AI will arise and want to dominate and kill us all, I thought, no, you're assuming AI is like humans. I mean, humans do like power. They do like to dominate. Not
mhm,
all of them are, are obsessed with it, but enough of them that is it's it's reflected in the kind of text AI would train on. And, and of course, humans also, they can be devious, they can cheat. There was the famous example, you mentioned kind of the evaluation of GPT-4, and there was the famous example of, the CAPTCHA, lying
mhm,
about the CAPTCHA, when it was given the task of recruiting people on, I guess, some TaskRabbit or some platform, and like texting with them, and uh I know they was going to recruit them to solve captchas, and one of the actual humans it was dealing with to do that, it was trying to recruit, said, well, wait a second, are you a bot? Is that why you want me to solve this captcha? And it said, no, I just have eye problems or something. And my assumption was that reflected the fact that it had trained on texts in which people not infrequently mislead other people to get things. Does that sound crazy?
um, yeah. Well, so I don't think it's crazy to think. Well, so I don't think it's crazy to think that like AIs might do this type of deception in the future. Um, Sorry, maybe I missed the exact question that you're asking. Was it
Well,
just
the exact question is, I mean, you seem kind of reassured by the fact that, the AIs are training on human texts,
yeah,
absorbing human values. And I'm saying, well, actually, humans can be very power hungry. They
right.
can be deceitful. So, like, a lot of things you'd worry about might be inculcated in them by virtue of them training on human
Mhm.
texts. And I thought the CAPTCHA thing was an example, but I don't honestly know why it performed
Yeah.
that deceit. I don't.
Yeah, and to be honest, I'm like not super familiar with like that example either, so I won't
Okay.
comment on it. But what I will say, yeah, so I think I actually agree with you. So I think um, a lot of people like Eliezer Yudkowsky and people who are like quite worried about like AIs going rogue. I think their general kind of like overall what they tend to think is that AIs will be very alien to us. They will not have our values, and they someone like Eliezer would say, well, the AI is going to have alien values and it will want to dominate not because it got its domination instinct from humans, but just because that's kind of inherent in what it means to have values, or there's some kind of like in principle logical argument for why you would want to dominate. So that's how they tend to think about it, is that the AI will be too alien. Um, but I agree that like, so here I am, I'm saying that AIs will probably be like quite human-like. I agree that like just being human-like is not sufficient to be aligned or safe or friendly, because like obviously humans can be power seeking, etc. And I think in the like 1% of scenarios where I think like an AI could go rogue, I actually think it's like pretty plausible that like the reason the AI would go rogue is that basically it learned to have like kind of instincts of like domination or revenge or some like negative
Hmm.
um aspects of human nature, and we weren't able to kind of like train those instincts out of it. um but I guess maybe to get to the point of like why I'm not super worried about this is that I think we have two basic tools that we can use to really kind of reduce kind of basically to increase the influence of our better angels. So like Steven Pinker has this like,
Hmm.
well, he like wrote a book called Better Angels of
Right.
Our Nature. So we have like two different tools that we can use to kind of increase the influence of our better angels and like decrease the influence of our uh, whatever the opposite of better angels is. Anyway, so that
Or worst devils, I guess.
yeah, yeah.
Uh,
Um, right. So the first tool is to just do really good filtration and curation of the training data, right? So I think some of the earlier language models, like GPT-3, for example, they were trained on essentially just a scrape of the internet. There was like very little curation that they actually did. I think they used like Reddit karma or something, but like it was not really very well curated. And so there were like a lot of examples of um, uh, bad behavior in that text. But increasingly, what we're seeing is that people are realizing that the quality of the data matters a lot. And so we're increasingly seeing people, looking into ways to like carefully curate the data that you're training the AI on. And also, what some people are doing is using synthetic data. So they'll basically take an AI that we've already trained, like a language model that we've already trained, ask it to generate a bunch of uh, new text, and then that and we're prompting the AI to make sure that the new text it's generating is like not toxic and is educational, etc. Um, but anyway, basically training new AIs on the synthetic data that is generated by like the previous generation of AIs.
and what is the
Um,
value of that supposed to be? Originally, I
mhm.
was hearing concerns about that, like there would be degeneration of data from human to AI generated, and then it would train on that and get even worse, and so on. But
Mhm.
you're saying there's value in.
Yeah, right. I mean, I definitely think there's ways that it could go wrong, but I think overall it's like quite valuable and like a pretty good direction in a couple different ways. So I think um, if we're talking about safety, I think we can use the synthetic data um, to basically make sure that there's like very few examples in the training data that are kind of basically we want the AI to know about the bad things that humans do, but we don't want it to actually imitate those bad things,
Mm-hmm.
right? And so basically, when you're generating the synthetic data, what you want to do is you want to sort of there's sort of like an art to it, and we're kind of like just starting to learn how to do this, but
So,
you want to
like, is bad behavior described disapprovingly or something, or?
Yeah, I mean, so that could be one way to do it. It could be kind of in quotes or something like that. There's a lot of different ways to do
Mm-hmm.
it, and I think we're just now at the beginning of like trying to understand how to do this well. But I think, yeah, I think we have some empirical evidence that this does actually reduce like
So that's
toxicity and
interesting.
stuff.
So you're in effect making it aware of kind of all dimensions of human behavior so that it can speak intelligently about it.
Mhm. Yeah.
But you're making only some of that behavior the kind it will, in a sense,
Mhm.
emulate.
Yeah, there is one paper that so like the simplest possible thing to do, which was described in a paper like last year, is to literally just add two special words to the AI's vocabulary, like good and bad, but like good in like special like letters or whatever. Like it's like different from like
My
the actual word
parents
good.
did that with me,
Um,
by the way. It's not an original technique, but go ahead.
but yeah, you just like have like special tokens like good with like capital letters and G and bad with capital letters. And then basically you surround like you train it like you train the AI like usual, but you surround the positive uh like positive role models with like good uh like
Hmm.
tokens, and then you surround the like negative role models with like the bad tokens. And then basically when you then use the AI like after it's been trained, you just stick the good token or like the good word at the beginning of the prompt, and then it will like then it knows like okay, I should be like emulating like the good role models I've seen during training. Hopefully that kind of
And
makes sense.
and you could make that just kind of a default thing. Like, in other
Yeah,
words, before you send it out there, you are basically putting good before every
yeah,
prompt that anybody
yeah,
writes.
yeah, basically.
Huh. And that, is it possible to say like what kind of specific behavior that would discourage?
Yeah, so I think it really depends a lot on like the specific use case and what your what your goals are, right? I mean, I think
Hmm.
um, companies like OpenAI and Anthropic are they're trying to prevent their AIs from being used for certain types of things like I don't know, hacking or like creating
Hmm.
um, you know I mean in some cases like creating porn or like there's like certain things that they're like trying to prevent. And I think it's just going to be really context dependent, like what you actually consider to be bad. But
Hmm.
um,
So, back to concepts. Maybe we
yeah.
could kind of start, see if I got a basic understanding of kind of how these things work. So, um, you know, so you have, well, let me ask it this way. They have these things that they call neurons,
Mhm.
and are they are they thought to be somewhat genuinely analogous to human neurons? I mean, in the sense that a bunch of them are connected to a bunch of others in some way,
Okay.
or at least communicate with others in some sense.
I mean, yeah, so at like a very high level, you could say that they're analogous. I think the one of the big disanalogies between these artificial neurons and like real neurons in the brain is that they actually have more connections than the usual like neuron inside a human brain. So like human
Mm,
brains
mm,
are sparse in the sense that like one neuron will tend to like connect with maybe like 1,000 other neurons. I'm just that might be off,
yeah.
but like something like that. But it's not connected like all the other neurons in the entire brain. With artificial neural networks, they tend to be what's called fully connected, or like this is like a common architecture,
Hmm.
which means that like you have these layers, and like all the neurons at one layer are connected to all the neurons at the next layer. So yeah, there's like quite dense connectivity between these neurons.
Now, is the number of connections the same as the number of parameters?
Not quite. They're like somewhat. So the parameters are, well, they are close, but not exactly.
Okay.
It's close because most of the parameters are determining the connection weights, like how strongly the activation of this neuron should influence the activation of this like neuron ahead of it, and whether it should be like a positive influence or like a negative influence. But there are some parameters that like do other things, so it's not like an exact.
Okay. And so back to so my understanding is it's a fairly generic learning machine, in the sense that, well, let's take the case of predicting words. Okay. So you give it the first part of an actual sentence that was found out there on the internet, and you say, okay, predict the next word. And it has a system for translating this input into output, which is the guess about the next word. And basically, if it magically gets it exactly right, then you would say, then that's positive reinforcement for the specific, kind of weights, whatever, the activation levels of the connections, however you want to put it, that exist at that point, right? And anyway, when it gets negative, when it doesn't get it right, it kind of tries again and adjusts the weights to some extent. It just does this over and over and over. Yeah. And there are these feedback mechanisms, I guess, back propagation or something, that make it not a merely random exercise. In other words, when it tries the next time, it has some feedback about what's likely to make it better as opposed to worse. And so it just does that. Now I have another question, but so far, is that kind of close to right?
Yeah, that's roughly correct. I guess I would just say it's actually highly non-random. So there's actually the algorithms that we use actually have convergence proofs under certain assumptions, but the assumptions are like usually met, where basically because every iteration you're only changing the connection weights a little bit, like not a ton, just a little bit, you can prove that the like direction in which you're moving the weights is going to improve performance or reduce the cost or like the error, at least by like a little bit. So yeah, it is like. Yeah.
So it doesn't just say right or wrong in a certain sense, broadly speaking. The feedback isn't just right or wrong. It's you're getting closer or you're getting further away. Okay, so the kind of amazing thing is that, again, none of this involves telling it what these words mean. They're just symbols to it. And yet, in the course of getting better, it does build a kind of semantic landscape. I mean, the very highly simplified version of this would be, suppose that you were rating fruits on like 2 dimensions, X and Y. One is size and one is roundness. So on, like limes compared to oranges would have the same roundness thing on the x-axis or whatever, but on the y-axis, of course, limes would be lower. And then bananas, whatever. You get it. You could, in principle, map every fruit along those 2 dimensions. And these machines create like tens of thousands of dimensions, and not all of them are semantic. We should specify that, but just kind of put it aside. Just think about the semantic ones. I guess and that is part of the way it generates such good results. And then, well, to add a little, so the input, the sentence, the first part of the sentence that it's trying to predict the rest of is quantified and goes into the system. And if the connections have gotten to a point where they're really good, in other words, the model is mature, it's gone through learning and everything, then they will generate a number that's a bunch of dimensions. It's like 3 comma 5, whatever,
Yeah.
like tens of thousands of dimensions. And that will represent a point in space I can't conceive of because it's more than 3 dimensions, but a point in space. And the machine will look at that point in space and pick the word that's closest to that and say, okay, this is the one. Or else if it's supposed to be a little more random than that, it'll choose randomly among the several close or whatever. But that's what it does, right? Roughly speaking.
Yeah, at a high level, I would say, yeah, I think maybe I'm not sure how important this is, but maybe one detail that you didn't mention is that so all the language models that we currently use, and this is true even for like not language models, their output is not they don't directly output a word or like a token. What they output is a probability distribution.
Mm-hmm.
We say like, oh, this word is like 30% likely. This word is, whatever. For like all the words that are in the vocabulary, which is usually like 50,000 or something. And so they output a probability distribution, and then you can like sample from that distribution.
Okay.
And that's actually why language models they're like often not deterministic, because there's like this random sampling that's going on. But the probability distribution is kind of important because it means that it's really easy to give like fine-grained feedback to say like, okay, you should put like a little bit more probability on this and a little bit less probability on this. So it's all continuous. And because it's all continuous, that's actually why these like backpropagation algorithms work so well, is because it's continuous and we can say like a little nudge in this direction will make you like a little bit better at predicting the next.
Okay. So, but we can still think of it, of the number it comes up with, of it kind of coming up with a number that specifies a point in space, and then the most probable answers in that distribution are near that point in space, in multidimensional space. Now, one question I have is, when they first like built these models, did they know that the way the machine would handle the challenge would be to build a multidimensional semantic space? And again, there are also syntactic dimensions and so on, but or was even that kind of a surprise?
So yeah, I think it was a surprise to many people, although not everyone. I mean, I think there's this idea in kind of linguistics and computational linguistics called it's called distributional semantics, which just means that the meaning of a word, it's kind of like a hypothesis, I guess. It just says that the meaning of a word is like entirely or mostly determined by the like words that tend to be nearby it, or like the words that it tends to be associated with. And this idea was around for like in some form for like maybe over 100 years. There's like structuralism, and so there's like ideas kind of floating around like that. And I think if you take the distributional semantics seriously, if you take the idea that like words get their meaning from like their relations with other words seriously, well, it kind of makes sense that if you build a machine whose job is to predict the next word given the previous words, like that's like almost the same thing as determining like the meaning. But of course, not everybody agrees with distributional semantics, and even if they did, they weren't really like thinking about it in that way. So it was a surprise to many people, but not everyone.
So it shouldn't shock us. But like, do we know of an actual person who, before they actually started making these machines work, said, "Oh, I know how it's going to do this. It's going to be,"
Yeah. So I think like probably. Well, so I guess I would say people like Yann LeCun, so he's like at Meta
He's at
now.
Meta. Yeah.
Yeah, but he's been in like kind of pushing for like deep neural networks for decades. I believe Ilya Sutskever would also be in this camp. Well, actually, I'm not sure what his current status at OpenAI is, but at least for a while he was at OpenAI. There are like certain people who have been kind of pushing for like deep learning and deep neural networks for decades, and I think they mostly kind of understood that like something like this should work, but I think mainly for computational reasons. Like it's just really, it takes a lot of computing power to like train these models. They weren't able to scale them up to
Hmm.
the sufficient scale to kind of see what we're seeing now. But
But
I think
but
they were pretty visionary.
in any event, we didn't have to specify that approach to the solution, right? We just
Mhm.
built the learning machine, and the
Yep.
machine built that approach, which is kind of amazing. And so
Mhm.
now my next question, which will bring us back a little closer to alignment, is this idea of concepts residing somewhere in there and our trying to find the representation of concepts, uh, possibly for purposes of altering them or erasing them for the greater good, kind of, I gather.
Yeah.
Um, how how close are we to that? Now, I know there was a paper not that long ago, um, by among other people, Dan Hendricks, called Representation Engineering, the top-down approach to AI transparency, where they talked a little about concepts. I think the example they used was just a concept like a dog or something, not something very abstract. But I I thought they were showing that you could actually, once you identified the concept, you could reach in and change the properties associated. Like you could make the LLM think the
Mhm.
dog's meow instead of bark or something.
Yeah.
It
Exactly.
that is that kind of thing we now know is in principle doable, and we have some idea how to do it.
Yeah. So it depends a lot on like the exact concept and the exact model, et cetera. But like in some cases, like we can actually do this. Like we've actually like shown that you can like locate the concept and edit it, and it has the effects that you would expect roughly.
Hmm.
Um, so yeah.
And is it possible to say, like to a layperson like me, who has only heard what we've said so far about roughly speaking the way these things work, like what form does the concept assume in the model?
Yeah, right. So I think you were mentioning earlier about I'm not sure if you use the word embedding, but the word is embedding. When you were talking about like the model creates like a bunch of different numbers. That's like a high
Huh.
dimensional space. Um, yeah, so like the model kind of like uh, yeah, so I mentioned earlier, like these models tend to have layers. They might have like 10, 20, 50 layers. And like kind of inside of each layer, it's doing like mathematical operations on these kind of points in a space of more than 3 dimensions.
And are
Might
these
be thousands
layers
of
of
dimensions.
neuron? These are layers of neurons.
Yeah, yeah.
Okay.
Um,
So it kind of
and yeah,
moves from top to bottom. If you imagine like levels of layers of neurons, it
mhm,
the input moves through.
yep.
And okay, sorry, go ahead.
No, it was fine. Yeah, so like each of these layers is kind of operating on these embeddings, which are points or vectors in this like high dimensional space, could be like thousands of dimensions. Um, and what we tend to find is that there, like, if you kind of specify a like a human concept, like you mentioned, dog, or like true and false, or like male, female, or something like that, you can usually find a direction in this high dimensional space that is like is associated or kind of encodes this concept.
By
Um,
direction, you
mhm.
mean like from one point in multidimensional space toward another point? It's like
Yeah,
it's
yeah, it's
because
sort
like
of
a
like if
word
you
is a point in space, and
yep,
is this like a line in space or what?
yeah. So um, the way to think about it is like um, if you start at one point and then you like move in this direction, then I guess you could think of it as like there's like north, south, east, and west. There's like northwest, southeast. There's like left and right. It's kind of that type of thing. Um, but
Hmm.
like it's like the high dimensional like generalization of that type of
Hmm.
concept. So it's like if you start at this point and then you go like northeast from that point, um, then you will like tend to cause the model to think that the input is like um, true rather than false, or you'll like cause it to think that there's like it's more likely that there's a dog there, or something like that. That's kind of the idea.
Yeah. I'm not sure my brain is capable of conceptualizing this thing, but it's almost like a local kind of current or direct wind direction or something. I mean, it's like,
Yeah. I mean, yeah, I mean, maybe another way of thinking about it is like you can like imagine the set of all the examples. I don't know, maybe let's think of like, yeah, I guess we'll stay thinking about like language models, and you'll um, feed the model a bunch of true statements and a bunch of false statements, and you like look at their um, embeddings, like the embeddings of the true statements and the embeddings of false statements. These are like big kind of clouds of points, right? Um, and then you can look at like, okay, what's the like center of these like point clouds? Like there's like if you like take the average of all the points, that's like the centroid or the center of each point cloud. So okay, so then you have like the centroid or the center of all the true statements, the center of all the false statements, and then you're like, okay, now there's like a direction. You can like consider like the line that like takes you from one of these centroids to the other.
it gets truer as you travel it.
Yeah, right, exactly. So yeah, so like as you move from the false centroid to the true centroid, you're like getting truer and truer and truer. And then, so this is, you can call it like the truth direction. Um, it's like the difference between the center of the true statements and the center of the false statements. And we in fact find, and this is like part of like my paper on concept erasure that you kind of alluded to earlier, we in fact find that like doing this exact operation, like looking at the point cloud, finding the centroid, and then like looking at the kind of direction that takes you from one centroid to the other centroid, like this direction is actually the direction that you care about, and the direction that you can like manipulate, like use to manipulate the model and so forth.
And you've demonstrated that you can reach in and successfully manipulate it and change its output.
Yeah, so that's like partially my work and partially the work of some other people, including like Max Tegmark, his lab, and Sam Marks, I believe, is one of his students, a postdoc. But anyway, they did a paper recently that was kind of along the same lines, where they like were able to manipulate the model's beliefs using this technique.
Okay. I mean, I guess one obstacle to my comprehension among others, including my brain, is like I had imagined that words might have a location in multidimensional space, but I hadn't imagined like statements having that. I mean, I know they have, like one thing they did, I don't know if this is related to your work, I gather like it had to do with like, what was it? Is the Eiffel Tower, so the Eiffel Tower, it kind of knew that the Eiffel Tower was in Paris. And then if you change that to its thinking the Eiffel Tower is in Rome, you could, this isn't the exact example, but then you could get it to say that the Eiffel Tower is close to the Vatican, which is almost like logic, but which in some respects these things are bad at. But so that's the kind of thing we're talking about here, right? Like the factual.
It is related, yeah.
Yeah, it's related, not the same thing. But anyway, you know what I mean when I ask, like, wait a second, you're saying that statements or facts or also have a place in this space, but you're saying they kind of do?
Yeah, so they do. Although you are, yeah, I guess you are pointing at an interesting point, which is that so at least in like the language models that we usually use currently, there actually is only like one embedding per word. Technically, it's a token, but it's basically the same thing. One embedding per word, and there isn't, strictly speaking, an embedding for an entire statement or sentence. But what we find is that we can usually locate we can locate a word inside of a statement that sort of summarizes or kind of carries most of the semantic content of the entire statement that we took it from. In particular, like punctuation, like the period at the end of the sentence, tends to contain a lot of semantic content about the entire statement that came before it. There's a paper actually out of Eleuther that found that. And so yeah, you can usually find a word that kind of summarizes or contains the information of the whole fact that you're interested in.
So am I right in thinking then that when it says a dog barks, it isn't just that it's repeating what it's heard. I mean, maybe in that case it is, who knows? But there are cases where the fact that a dog barks, or the conception of a dog as something that barks, has a coherent representation that involves some kind of pattern of information or something that in principle you could point to, so to speak. You could locate it for, and kind of manipulate it sufficiently well to just change the concept or change the fact, right?
Yeah, so I guess I'll say it kind of depends on like what type of information you're interested in. Like I think that if what you're interested in is like causing a model to like if what you're interested in is like taking a particular statement and like causing the model to like treat this statement differently by like manipulating one of its concepts on this particular statement, I think that's like fairly easily, and there's still some work to do there, but I think we kind of know how to do it probably. But if what you're interested in is like editing the model's like behavior overall, just like on any input, like generally changing it so that it thinks that dogs don't bark anymore or something like that. We do have some tools to do that. I'm not going to say, we have some tools, but I think it is just generally a somewhat harder problem. And it's like the tools that we have right now aren't completely robust. Like what will tend to happen is that, you'll edit the model to say dogs don't bark, or the Eiffel Tower is in Rome, and it will act that way in like a variety of contexts, but not quite all contexts. Like sometimes it will kind of remember its like past, like the correct answer, or like the answer that it believed before. So yeah, I think it's still somewhat of an open problem to like thoroughly edit these like beliefs. Hopefully that makes sense.
But the fact that if you want to get it to, in a lot of contexts, say dogs meow or or whatever, the Eiffel Tower is nowhere near the Louvre or whatever. The fact that you can do it the way you're doing it, rather than having to go back and change all the training data and start all over, suggests to you pretty strongly, and I gather to researchers generally, yes, there is such a thing as a representation of concepts in these machines. And that's related to, but different from, the mapping of individual words in the semantic space.
Yeah, I would agree.
So this is kind of amazing. I mean, is it your view that as it does this, I mean, a term I've used when I first heard about, like, the fact that, the semantics emerge rather than being built in, is like, in a way, the machines are kind of reverse engineering the human mind almost. In other words, they're taking the output, just the surface manifestation of a human mind, the way it puts out language in response to other language, stuff like that, and it doesn't even know what the language means. And yet, in order to become good at doing what humans do, it starts kind of, it builds things that are somewhat comparable to features of the human mind.
Yeah.
So that is kind of amazing. I mean, do you have an intuition for how precisely it does that? Like as you said, the idea that what humans do is kind of a semantic mapping is still just a theory. I mean, it's going to turn out that it winds up telling us how the human mind works, as it gets better and better?
Yeah, I guess maybe um, to kind of rephrase what you just asked. So are you kind of asking like how similar we should expect, like how similar are these language models to humans, or is it like a
Yeah. In other words, is it just building these internal mechanisms that just happen to work well enough, or does it tend to be the case that it actually that we're going to find that it's actually to some extent a mirror of the way human cognition works at some level of abstraction? I mean, not precisely.
yeah? I tend to think so. I think overall it's kind of like this question is tricky because it depends on like what do you mean by like similar or something like that. But I think like in general, I think that as you scale up these models and train them on more data, like basically as you train them on more data, like you're kind of restricting the space of possibilities more and more in some sense. Um, so like maybe, and I'm actually looking at this in some experiments currently. Early in training, when the model has only seen, you know, a few thousand examples of human text or something, you shouldn't expect that it's learned anything like what humans do, right? It's
Hmm.
probably just using very simple heuristics. But as it learns more and more, and it gets better and better at predicting human text, like I do tend to think that like it's there might not be like a literal one-to-one mapping between like circuits in like a human brain and circuits in the AI's brain, but I would say that um, the mechanisms it's learning are quite robust. Like you don't tend to find that on like some new type of text that the model hasn't seen before, it like goes crazy. It usually like kind of reacts in like a fairly reasonable way that's kind of human-like.
Okay. Well, listen, we've been talking close to an hour, and what I usually do on the podcast is, do a lot, most of the conversation, or at least half of it, in public, and then the rest, the overtime segment, is for paid subscribers, Nonzero newsletter. And you have been kind enough to stick around for that part, so we're going to keep talking, but once we're in overtime, that'll the only way to get access to that is to go to the Nonzero newsletter and subscribe. There's also a link in the show notes on your podcast app. Um, and I, of course, encourage people to do that. There's other stuff you get in the newsletter itself, but you also get access to all the overtimes in the podcast. Um, Before we go into overtime, I want to give you a chance to say anything else that you think you really want to add for the benefit of the audience that's been with us so far, but may not be with us for the rest of this. Um, Even like something mundane, like what's your Twitter handle? I know you're active on Twitter.
Yeah, my Twitter handle is just Nora Belrose,
Hmm.
my first and last name. So yeah, you can follow me there. Um, I guess also we do. So so this is definitely separate from Eleuther, to be clear. This is not an Eleuther thing, but separate from Eleuther, I do have. Well, me and a few other people have this kind of blog website called optimists.ai. That's like optimist with an S .ai. And we do have some blog posts there that kind of make the case for like being fairly optimistic about the controllability of future AI systems. So,
You're my second consecutive optimistic AI person. I taped a conversation with Reid Hoffman, and I think you're the only two optimists I've had on. So I'm starting to balance the scales here. And one of the pessimists was the person who founded Eleuther. By the way, Eleuther is Eleuther.
mhm.
Um, Connor Leahy, whom you know, who's still on the board, but he's now started to conjecture AI, and is also doing, I guess, interpretability and alignment stuff, right? And so anyway, people that conversation
Yeah.
is in the archives. Uh, from the beginning, Eleuther has been kind of a champion of open source.
Mhm.
And when we get into overtime, I want to ask you why you're not as worried about open source as some people, and and ask you a number of other things. But anyway, thanks everybody's stayed with us.
Sorry, I should just
Yeah, sure.
sorry, just one last thing. I should also mention eleuther.ai is like the website of EleutherAI. And we
Right.
have a Discord server. You can actually just publicly go to that. It's like on the website, eleuther.ai. You can go to the Discord server. So
Okay.
that's where you can find me.
Okay. And now we will head into overtime.